Alrighty, good night. So welcome to Organic Nomenclature Part 3. In Part 3, we're going to be talking about a little bit more complex molecules, some including now what we need, what we are going to need is a priority table. You are expected to know the functional groups by now, so we're going to be talking about them as if you were an expert on them. Okay? So, with our molecule, the first thing we're going to do is to start identifying what are some of the functional groups there. So what functional groups do we have? So if you notice right here, okay, what we have is a carboxylic acid, okay? So we have a carboxylic acid, all right? We have here just a cyclo group, okay? We have here an amine group, so an amine here, alrighty? Here we have an ether, okay? And we have an ether. All right, so from all and an aromatic, okay? So now from the functional groups we identified, we're going to pick the one that has the highest priority. The one that has the highest priority will get the name of the suffix, okay? The other ones will become then ramifications or substituents, and you will be using the prefix. So the one we're going to be using the suffix for is the carboxylic acid, okay? So we're going to choose our parent chain. Where do we start our parent chain? As you know, it must start and end with carbons, our first carbon. Okay, it's in the carboxylic acid. This is not really a carbon, it's an oxygen. So try not to make that little mistake in there. And then to continue down until you find a terminal carbon. So our parent chain is going to extend and grab as many functional groups as you can until the end. Now, your most important functional group will be the one that you're also going to look for it to have the smallest number. So if your carboxylic acid is the most important, then you're going to have to start right there. So 1. Okay, you extend your parent chain, okay, numbering, okay, all the way to the last carbon, okay. Then you find your substituents names. So what would be the name of the substituents? Here we have, okay, a cyclopentyl group. So cyclo because it's a cycle. Okay, you have 1, 2, 3, 4 carbons in there. So pent. Since it's a ramification, is YL ending. Okay, an alkyl group. Then we have our amine. Now, our amine, we have shown it here before. Okay, since it is no longer the most important, we're going to then use the prefix, which would be amino. So the name for this is going to be amino. Okay, then here we have an aromatic group, okay, which from our special branches we mentioned, okay, that it was going to be called a phenyl group. Okay, so it's a phenyl group. All right, and then we have our ether. For the ether, you notice how many carbons it has. It has 1, 2 carbons, so it would be F. Okay, but then it ends in an oxygen. Okay, it's attached to the parent chain in an oxygen, so it's ethoxy, something like what we had over here. Okay, alrighty, so then alphabetically, what are we going to take into account? Well, alphabetically speaking, okay, for the cyclopentyl, we're going to take into account the P, since the cyclid does not tell anything about carbon number. Okay, the pent does, so that's what counts. The phenyl, the amino, and the ethoxy. Okay, alrighty, so the first name we're going to mention, then it's amino. Okay, then we're going to go to our ethoxy. Okay, so for the P's, since it's a P and a P, then you go to the next letter, H or E. Okay, so which one goes first? E. So this is going to be our third, and this will be our fourth. Okay, so alphabetically speaking. So let's go ahead and try the name for this little baby. So we have 4 amino. Okay, then we have here 5 ethoxy. Alrighty, then we have cyclopentyl, 2 cyclopentyl, and then with 6 phenyl. All right, then we're going to name our parent chain. So number of carbons in that parent chain is 8. So it's going to be oct. Okay, then we describe the chain we have right here. We have this double bond over here. Okay, this one. So we are going to name it a oct 7n. Okay, and finally we're going to use our suffix for this, which is going to be, according to this, oic acid. So oic acid. Okay, divided by space. So ready to try another one? Okay, so let's try a cycle now. Okay, so we're going to choose our parent chain.